Next to me is Frederic Güth from Fraunhofer ENAS in Chemnitz. He will tell us something about Parylene packaging on the next generation on PCBs. And I know that Parylene is working quite well because we had a joint project a few years ago with Parylene on printed electronics, so I'm interested to see how you developed.
Yeah, thank you very much for the kind introduction, and thank you everyone for being here for my presentation titled Ultra-Thin Parylene-based Printed Circuit Boards for the Next Generation of Flexible Electronics. My goal today is to introduce to some of you, or remind some of you maybe, about the properties of Parylene, a very interesting material, and what we are doing with it at Fraunhofer ENAS. So you see the agenda. I will present our vision for the ultra-thin Parylene-based printed circuit boards. I will go into some of the details of the material properties, and then I will show you where we're at, like what kind of processes and technologies we've tested so far, and where we see ourselves, and also at the end, obviously, I want to show you where we want to get to. Before I start with that, maybe just to manage your expectations, this work that I'm presenting here is not what I've done. It's was done by my colleague, who's unfortunately still in Japan right now, so he asked me to step in. That's what I'm doing. Just when it comes to very detailed questions, I might have to refer you to him, and might not be answer to all of your questions. So, let's start maybe by with a quick introduction of Fraunhofer ENAS, the Fraunhofer Institute for Electronic Nanosystems. You already heard that we are based in Chemnitz, which is roughly 2.5 hours south of Berlin. And what we do there is that we work on all kinds of MEMS, MOEMs, and also especially smart sensor systems. That's where we see ourselves. And in this field, we are active along the entire value chain. That means that we are we do design, we do simulation, we can do the entire device fabrication, so we have silicon MEMS fabrication lines available to us. We do the testing, the packaging, and then at the end also the assembly, PCB design, some software, and also reliability testing. So that's where we're active in, all that especially focused mostly on MEMS. At the bottom you see some of the examples of work that has been conducted by Fraunhofer ENAS, and we are roughly 250, maybe a bit more colleagues. This is our campus. So we work closely also with the Technical University of Chemnitz. We operate the clean rooms together, and so we have everything on site from design phase to testing at the end of fully functional devices. As you can imagine, or maybe a quick word about Fraunhofer itself, it's basically the equivalent to VTT in Germany. So we do applied research, which means that we are active in many, many fields. And one of those fields that I want to put emphasis on today is flexible electronics. Basically, this is a result of continuous work with the material Parylene, which I will introduce to you in the next slide. But first I would like to show you the vision that we have when it comes to these flexible circuit boards. So we want fully smart systems, whatever that is. So we need flexible PCBs, and we want to populate that with functionalities through chips, chiplets, or other components. And we set out by setting ourselves some goals. So we want to reduce the thickness. We want to focus on one material for various needs in this context. And the rest basically comes from just, if you want this functionality, obviously you need redistribution layers or metal layers and so on. So you need to be able to build a PCB based on this material. I will come back to this slide at the end, and we will check where we're at with all these bullet points. But for now, this is our vision, and we build this around this material, Parylene. Parylene is a group of polymers with very interesting properties, some of which are listed here. So it's a dielectric, it's chemically inert, biocompatible, and so on and so on. It's basically always the same structural unit, but through substitution you can achieve various variants of Parylene, which then again have slightly different properties, so you can fine-tune it to your application. which what is usually, or what is always the same is the deposition of Parylene, which is a 3-phase